Hello. All right. Of course, I have to follow that up with thanking Renzo and Alex and all the other people who took on the demise of Clojure Exchange, like full throttle, arranged the venue, managed to get sponsors on board to provide this event free of charge for you all, and so a big round of applause for those guys as well, please. Okay, so this talk I've given before in a 50-minute slot, so what I'm going to do today is speak at 1.6 times normal speed and just power through. Quick intro, although you saw me earlier, that's me. On a good day, creator of ReClojure the SMS hotline, which no one's used before today except me and my friends, but I'd be very pleased if you did. Okay? I've been lucky enough to be employed as a Clojure programmer on and off since 2010. Right now it's not my main job, but it's still my main favorite programming language. Okay, so Clojure in containers. What does that mean? Specifically for the purposes of this talk, it means talking about the JVM in containers. So a container is a way of running a process on a host, and the process, as much as you've written your code, I mean, you should turn off notifications, but I don't know how. So, don't send me stuff, please. I will be talking about the JVM in particular, so if you're a Clojure CLR person or a Clojure script person, some of this will be relevant, but a lot of it is JVM specific. Okay, so who is using Clojure on the JVM? Everyone, nearly. Who is using Java version 8? That should be most of you, according to this. So, Java 8, yeah. Java programmers are slightly slower to move to Java 11 than Clojure programmers according to these latest usage surveys that I could find. And I think that stands you in good stead. You'll see later about why. Yeah, cool. Okay, so what do we want out of JVM in a container? We want, well, to my mind, three things. Fast startup, right? Containers, and especially orchestrated containers by things like Kubernetes, they tend to cycle about 1 or 2 orders of magnitude more frequently than non-containerized workflows, right? If you're running, and I don't just mean production startup, I'm talking about CI/CD, development environment, all these kinds of places. Fast startup with JVM matters. Clojure's had a lot of flack through the years, and I'll show a couple of ways of speeding that up. Efficient use of container images, and a bit about respecting the environment. Okay. So the top tip, right, for fast startup is move startup activities to build time. And it's, sounds kind of obvious, so we're talking about AOT compilation, and the JVM itself does a whole load of things at startup, for which the result is actually exactly the same every time. So what you can do is, into your container building scripts, put things that do the startup activities and cache the results. And I'll show you an example of a couple of those things. Firstly, class data sharing and application class data sharing. So is anyone aware of these things? Okay. So class data sharing is a thing that in terms of Java is nearly old enough to drink, I think. It's been in Java since Java 5. So it's not a new thing, but application class data sharing is new in Java 10. It was what's it called? A feature you have to pay for when you have a contract with Oracle. But now as part of OpenJDK, everyone can use it if you're a Java. Well, why would you be using Java 10? So Java 11, right? So this is one of the things that JVM does at startup is it has to load all the classes that you're going to use in your application off of disk. They'll be as bytecode. It has to parse the bytecode. Some classes it will have to verify the bytecode. It will build in-memory data structures, and that all takes time. And the result of it is exactly the same every single time, right? So class data sharing and application class data sharing are ways that you can cache the result of doing that. The difference is the plain CDS applies to core Java classes, so the ones that are distributed with the JDK. Application CDS applies to classes outside of that, so i.e. like your application classes. I have a demo. So I'm sorry, I didn't realize earlier that people at the back can't see the top of the screen, so I hope if I pull this down, it's a bit better. So I've got a hello world type Clojure application. I built it into an UberJar with my UberJar, and I can run it with Java, MS, jar, target, that one, you lovely people. Hello, you lovely people. Right, there's a tool called Perf, which I've scripted, which is a Linux kernel tool for profiling how long applications spend on the CPU. And this script perf10 runs a thing 10 times, and it will tell you that this application takes on average 0.64 of a second to run. So I hope you can all see that. And a lot of that time is obviously not spent just printing hello world. A lot of it is spent doing the loading of classes that I talked about. So let's find out how much. So there's a couple of arguments, and these only work, remember, on Java 10 or later. Xshare is generally the thing that controls class data sharing, and we can turn it off and dump a loaded class list into. So whilst that's happening, does anyone have a guess at how many classes are loaded? 1,000?
50,000.
Right, thank you for providing an upper bound. It's between 1,000 and 50,000. Let's have a look, right? So I've dumped that file into appcds.classlist, 2,779, right? Where have they come from? I'm going to just pull the first part of the fully qualified name, right? Most of them from Clojure, 5 from my single CLJ file because of the way that the Clojure compiler generates extra classes. A bunch from Java, JDK, and these summaries that you're not supposed to know about. So, by the way, all the things I'm typing in all the slides, I'll put them online later. I was going to say later this evening until I found out that Uswitch was sponsoring the bar, so it'll probably be tomorrow. Yeah, probably Wednesday. Yeah, maybe after Christmas. So by using xshare dump and saying this is the shared classes file, I want you to generate a shared archive file here. It's done it. It's generated this appcds cache. So this is a 26 megabyte file that is the result of loading, parsing, verifying, building structures in memory for those 2,779 classes. And if I run it with, yeah, here we go, this one, perf10, so I'm going to run it 10 times again, xshare on, shared archive file is this file, we just run this. And remember before it was about 0.65 of a second, so here it's like about 2/3 of that, and that will scale with the number of classes you're using, right? So you can save about 1/3 of JVM startup time by using application CDS at the cost of adding that 26 or more megabytes into your container image. So there's a what's it called, trade-off there, which is something developers love, right? So it's easy to think about. Okay, so that's application CDS. The next thing, has anyone looked at GraalVM? Woo! Look, more people that think Graal. So you know that when you're running code in a JVM, first of all, the JVM runs an interpreter, so it reads bytecodes, executes them, reads bytecodes, executes them, and the name hotspot for the hotspot compiler comes from the fact that once it's determined where the hotspots are in your application, it can recompile the bytecode to native code. And so we've just sort of realized, as we've said it out loud, there is a part of the JVM that can compile bytecode to native code. Like, why can't we just do all that up front and not have a JVM at all, just run native code? That's what Graal does. I've got one of those over here as well. So before I do that, I need to use SDKman to switch over to use Graal. So there's a tool called Native Image that comes with the Graal distribution, a bunch of command line parameters, but then we give it the name of the jar that we're building. And this takes, I don't know, no more than 15 minutes, so just silent. So, no, it doesn't. It's done. It takes a few seconds, and it's built this file. Come on. There we go. It's built this 7 megabytes, and this is completely static, self-contained binary, so it doesn't need a JVM to run. It doesn't need any other libraries on the system. It doesn't need glibc or anything because I put --static. So you could literally have a container image with just this in, and it works exactly the same. To you all. Hello. Going to run it. Right, and it takes no time at all. But it's not free, right? Nothing's free, it's coded. What we've traded off here is peak performance. So we've got very fast startup, but in terms of peak performance, there is no runtime profiling and dynamic recompilation that the JVM will do to get really good peak performance. Also, the garbage collector that's built into this app is somewhat similar to serial GC, if you know that. So it's got a lot of stop world courses and that. But if you're interested in like building command line tools with Clojure, then by all means look at the Graph native image stuff because it's really, really impressive. I have to say that there is an open bug which prevents you using native image on things that have been compiled with Clojure 110. That cost me a lot of time in preparation for this talk. Hopefully that will be fixed. So CLJ 1472 if you're a Jira nerd. Okay, anyway. We'll keep going. Talking about efficient images. So now actually the bit of the talk is about containers because all I've shown you is running on my host. You can build all those things into a container image or do the build as part of your pipeline before and just add the files to the image. But now we're talking specifically about Docker container images. So two things that you want are small size and using layers of the image to your advantage. Small size, why? Because they get copied around all over the place, right? 100 megabytes takes on a very fast network a second, right? So if you just do a basic, I've got an example of here you go. If you do this kind of thing, how big is that image? Which is just from adopt OpenJDK JDK 11, add a jar, and add a command. Docker images. So that's half a gigabyte of image, right? For this, I don't know how big the jar is, but it's not very big, tens of megabytes, right? A lot of it comes from the OS, and a lot of it comes from JDK. Right, so top tip number one for image size, use a Alpine Linux-based image. Right, Alpine Linux is a distribution of Linux that is specifically designed to be small, and so it works very well in containers. You'll see that it's rather a chore to use because you need to change your Docker file to look like that, and just put code on Alpine on the end of the base image. Building your own from an Alpine distribution and adding the JDK is more complicated. Ask me why in pub. But the adopt OpenJDK Docker images that use Alpine base are exactly the same at runtime. They have a different layer of OS underneath the JVM, but you don't care about that because the JVM is an abstraction. It means you don't care about it. Docker is an abstraction. It means you don't care about where you're running. So abstracted a long way away, and that saves 104 megabytes, just with like extra 7 bytes in your Docker file. So I think that's a pretty easy win for you. Excuse me. Right. Next up, talking about using layers to your advantage. So, brief bit about, Docker layers. So each image is composed of layers. Each line in your Docker file creates a new layer. And layers, where possible, can be shared because they're read-only. So what this can up here is copy or write code, which Docker sort of puts at the top of the stack of layers. So here I imagine I've got 3 different Uber jars, all built on the same distribution, all built on the same Alpine Linux base image. That's all read-only. So files on disk and files paged into memory can be shared between these 3 running containers here, and only one of the running containers actually pays the hit for owning that memory. So it's a good way of cramming more stuff onto a single host if that's what you're going to do as well. But it seems like using UberJars here might be a bit of an anti-pattern because if you could instead make your application look like this, then you can share the dependencies layer. Because I'm not thinking that these would be 3 different applications, but rather maybe 3 different versions of the same application. We make code changes a lot more frequently when we add and remove dependencies. So being able to put your dependencies into a layer means that when it comes to pushing out a new version of your code, all the layers that are already on your production service or on your CI service or whatever, if your dependencies layer hasn't changed, then you only need to push the smaller layer that has changed. And here, on the top right, is a cool line plugin for helping you with that. Does anyone use line meta jar? No, great. I'm very pleased to be able to teach you about it now because it's cool. I only learned about it recently. Let's jump back to Emacs. Thanks to Emacs. Even John said he wanted a Clojure program earlier. Okay, oh, that's good, isn't it? So I put in line meta jar as a plugin. This is a different application, by the way. This is a Ring Composure web app that I've got building here. Line meta jar as a plugin. AOT my main method and say where the main method is, and then run. Where am I? Line meta jar. And instead of running line uber jar, what this does is it compiles my main method and all the dependencies of that into a thin jar, and it copies all the dependencies into this lib directory. Which is actually, it's slightly lying because it's in targets. So if I build a container image where everything from this directory is in one layer, and everything in my application is in the next layer, then we've got that kind of shape of, this kind of shape of layers. So how does the Docker file look for that? Oh, sorry. How's the Docker file look for that? Like this. I've assumed that I'm running line meta jar outside of the application. So this is a layer that's adding the lib, and then this is a layer that's adding into a different directory, the directory above it, the jar of my application. And what meta jar does is it puts some meta information in the jar, this one, that says where all the dependencies are. So I don't need to specify a class path or anything here. I just do java minus jar, this thing. To be honest, the size of this isn't any different. This is still just under 350 megabytes, but the way to use the layers means I can make a code change and push that, and it's much quicker to push that around. So line meta jar is a good tip for structuring your Docker files nicely. One of the biggest components is in the Docker image is often people's code and dependencies, especially dependencies. I don't. So this is 7.5 megabytes of jar dependencies, but I've seen applications with hundreds of megabytes. There is a cost, like it may save you some code to be able to use a library, but if it's a big library and it has lots of transitive dependencies, be aware that there's a cost of bringing it in terms of the amount of data you have to ship around with your application. So I'm not telling you directly to copy and paste code off the web instead of using dependencies, but sometimes that might be a trade-off that you want to make. Right, finally, respecting the environment. So I glossed over it very quickly earlier, but a container is a process that runs on the host, the same as any other process, except that it's subject to a whole bunch of restrictions. It might have a restricted view of the file system or the process space, so you can't tell what other processes are running on the same host as you, and that's kind of container isolation. It might also be restricted in terms of what hardware resources of the host that they're allowed to access. Right? So the container environment has a restricted view of CPU and memory of the host. And this is important because the JVM self-tunes based on the available RAM and CPUs. And you're probably all aware of this, right? Because depending on how much memory you've got, you get a heap size that sort of scales somehow with that. But it's not only heap size. The JVM does lots of other self-tuning. And this self-tuning process is called ergonomics. And it affects a lot of how the JVM runs in different hosts. And it lets you kind of be a bit blasé about running Java minus jar thingy wherever you are. Works. So specifically, depending on memory, heap space, memory pool sizes for the JVM itself, compiler, as in the hotspot compiler, excuse me, and the garbage collector, And perhaps surprisingly, even which garbage collector is used is set depending on how much memory is available. And different GCs have very different properties at runtime. Some of them are able to work in parallel with your application, some of them have big stop the world type clauses. So it's very important if you're profiling something to know which garbage collector you're going to actually be using at runtime. Then, depending on available CPUs, Ergonomics selects thread pool sizes for itself, but also this method here, runtime.getAvailable CPUs. And that is, its recommended use case is to size your thread pools, right? So core async does it, fork join pool in the JDK itself does it. Lots of libraries. When you need to know how many threads fit into the thread pool, you need some notion of how many things can happen at once. And you pull runtime.getAvailable CPUs to find that out. Fun fact, this is not guaranteed to be a constant. It can change during the runtime of your application, especially if you're in a container. You can poke Docker to say, give this one more CPUs and give this one less CPUs. And as far as I know, no libraries actually resize their thread pool when that happens, but it is possible. So, good news everyone, this isn't your problem. This is a problem for JVM engineers because it's not transparent, right? If you look in /proc/meminfo, you will always see the total amount of memory that your host has. If you want to know how much memory your container is actually allowed to use, you need to look somewhere else. So, since Java 10, there have been things switched on in mainline OpenJDK to respect container resource limits, and that's been backported into Java 8 if you're at U212. So who's using Java 8? And who's using later? Who knows whether they're using later than 212 or not? Not so many hands on the second question. I recommend, at the very least, upgrade to the latest 8 and look at upgrading to 11 because it has more features, like they're not all being backported as they're adding, but the main ones are. So we can check what effect Ergonomics has by with this catchy line here. We're going to run adopt OpenJDK, adopt OpenJDK Alpine, and we're going to use this flag here, XX print flags final. And then we're just going to give the JVM something to do by asking it what version it is, otherwise it prints out this line help description how to use it. And then we can grep for ergonomic. But before I do that with the grep, I'm going to ask how many JVM command line arguments you think there are in total. Thank you again for the upper bound. I was very pleased when I discovered what the number is actually. So if I do Java, I'll do it without the grep. So just running print flags final. Right, off they go. So look at the bottom. There are. Oh, I need to perhaps make my screen a bit narrower so that each thing doesn't run into 2 lines. Sorry if that makes it hard to read. So at the end, there are 3 lines of output from the dash version, and everything else is part of the print flags final, right? So I'm going to pop WC minus L on the end of this. So remember to subtract 3 from the answer. 666. If we, they're all documented unofficially. Very few of them are, a lot of them are like internal use only, like you would never need to touch them unless you're a JVM engineer trying to tune things, but there's not that you can do it. So if I grep for ergonomic, we can see how many of those are set by ergonomics, and it's, let's just narrow this down so they all fit on one page, because it's not so many, it's not so scary once you see it like this. There you go, there's that many that are set by ergonomics, and they're all the things you'd expect, like thread pool size, GC thread pool size, another GC thread pool size, GC cache area size. And at the bottom, use G1GC set to true by ergonomics. If I run the same command but provide -M1024M, so I'm restricting my container to have a gig of memory to it, that's disappeared. And we've got use serial GC, which behaves very, very differently under load. So there's a real thing to be aware of with how ergonomics interacts with containers. If you're testing your performance outside of production for some reason, and you're assuming G1, GC, and then you're running Kubernetes applies these memory limits, so you can apply them by hand, like I've done here, you may find like very different to what you expect. The changeover point from 0 to G1 is about 1700 meg. So if you're going over 2 gig, G1 is like the sort of flagship default garbage collector and generally has very good performance. Serial is renowned for stop the world pauses. Okay, that's all. Actually, I have for you. I've raced through it at 1.6x regular speed. So thank you very much. I'd be very pleased to hear if you're able to apply any of this to your daily work. And like I say, we'll have the slides and all the scripts and the document files and everything up. What did I say? Like Wednesday, sometime after the use switch bit.